Hello everyone and welcome to Rational Science. What do we do here? Well, we do science and primarily we do physics. Or most of what we do is physics here. And we're different than everybody else. In what way are we different? Well, everybody else does this. Everybody else does particles. Particles, particles, and more particles. Okay? And it's known as the ether. It comes to us from the Greeks. They believed also that everything was particles, and nothing has changed in the last 10,000 years. Okay? Now, some people believe that space is particles, and particles is space, and space is ether, ether is space. In other words, that space and ether are synonyms. That is the same thing when we talk about one or the other. Other people have this notion where particles of ether are contained within space. In other words, space is the container of all these particles. And either way, whether you choose what I call the infinite ether, this one, or the finite ether, this one, it doesn't matter. Either way, you got to identify what the black stuff is. The particles we more or less understand, but what we need to know is what's between each particle. What gives shape, what gives background to the particles. That's what we need to identify. And that's where people run into trouble. Okay? Now some people say, well, I don't believe in the ether, I don't believe in particles, I believe in waves. Well, it turns out that what they're waving is the ether. What's waving, if not the particles? In other words, you have to identify as what is waving. A wave is not a physical object. Wave is a verb. And you just have to explain what it is that is waving. Okay? What do we propose instead? Well, we propose this. We propose that there is a single closed loop thread in all of space. Okay? And this forms or comprises all the matter in existence. Okay? This thread converts to something that looks like this. It gets twined around itself. Okay? And from there it forms atoms and the anti-parallel threads, twine threads that bind any two atoms, that interconnect any two atoms. And that's the universe down there. The right-hand side, lower right-hand side, every atom in the universe is connected to all others through what we call the electromagnetic rope. And that rope also makes up or constitutes the atoms. Okay, so that's the model, okay, that we're proposing, and that's different than the one proposed by mathematical physics and the rest of the world, really. Okay, and this is another view of that. You can see that the single closed loop thread twines around and eventually turns into all this mesh, right, that is interconnected atoms. You can also see that or visualize that as interconnected galaxies, interconnected stars, because every atom in the universe is physically bound to all others. That's the model. And then at the bottom you see a two-dimensional version of the atom, or the atom we propose, the hydrogen atom we propose on the lower left-hand side, and a three-dimensional version on the right-hand side. They're both connected by what we call the electromagnetic rope. Okay? So that is the model, and here's the difference between what the rest of the world proposes and what we propose. Okay, this has been for the last, again, 10,000 years. Discrete particles. And on the right-hand side, you'll see what we came up with at the dawn of the 21st century. We propose that all atoms in the universe are interconnected. Okay, so that's essentially the overall picture of what's different about this site from all the rest. And here's the problem we find with the current models. You have to remember everybody and their mother uses the quantum atom. The little bead, the planetary atom going around the nucleus. Everybody uses that. Whether they explain ionization, or they're going to explain electricity or whatever, they're going to use that atom. And then they're going to deny it. And then they're going to use it again. That's how it works. Okay, and so this is the atom that everybody uses out there. and that is a little electron ball, which is that blue little ball going around. When it falls to a lower energy level, it emits energy, a concept called energy. Okay, and that energy is supposed to be light. Okay, so light is allegedly energy. Whatever energy is, they never define the term. They don't know what energy is. And in the middle of that atom, you see the nucleus, and that nucleus is composed of, in this case, we've got a hydrogen atom, so that is a single proton. And that proton is made of 3 quarks, which are held together by gluons, or otherwise known as the strong force. And the issue there is that the way it's depicted, it's always depicted as a spring, like bed springs, holding the quarks together. But when you look at the standard model, you'll never find those bed springs. What you'll find is particles, and the question is, how do particles contain or keep the quarks from flying away? Among other reasons, you got another problem with this, and that's the fact that you take any 3 balls like you've got in the center there, and you cannot make a sphere with them. So you can't make a spherical proton the way they always illustrate the proton. You can't do it with 3 spheres. But I challenge you to do it. Take any 3 balls, like tennis balls, and see if you can make a sphere with them. But they always paint the proton as a sphere, and they talk about it being spherical, right? They talk about radius. When it's made out of, according to them, it's made out of 3 quarks. So good luck with trying to get 3 balls to look like a sphere. Okay, so they have a lot of contradictions in their models, in the ones they illustrate. And in the end, they always tell you, well, they don't understand their own models. They cannot visualize. Niels Bohr said that essentially. He said, don't try to even visualize the atom. The quantum world, you will not be able to visualize it. So these people are proposing physical interpretation based on an assumption that they cannot illustrate, that they cannot even picture, they cannot visualize. And that's the status of mathematical physics today. Okay, and because of that, because they cannot explain anything, what they have invented to cover those holes, because you would think that, if you apply what they call Popperian falsifiability, Karl Popper, he was a philosopher of science, Austrian, and he said, look, the scientific method, it should be based on falsifiability. If just a single experiment, a single incident, phenomenon, whatever, observation, falsifies any aspect of a theory, that theory is dead until you can justify it, in other words. And so instead of throwing all of quantum in the garbage can where it belongs, particles, discrete particles, what they did is invent principles to cover those holes. And one principle is more ridiculous than the other one, more surrealistic than you can imagine. And these are some of the principles, not all of them, but these are probably among the most important principles that they came up with in quantum mechanics. One is complementarity. That means that this photon is both a particle and a wave. They later extended that also to electrons, and today they even say that everything is a particle and a wave. Everything, even macro objects. Uncertainty principle, when the ball moves, it doesn't stand still. When it stands still, it doesn't move. No kidding. Guy got a Nobel Prize for that. Discreteness, particles are entirely enclosed by space. Okay? But space is made of particles according to quantum. You have these negative and positive particles. They get together and they form space particles. In other words, no particles at all. And then somehow these no particles split into 2 particles that come into the world and do their magic, just when the mathematician needs them. And they're not talking about particles. They're really talking about amounts, because that's what a mathematician does. They call themselves mathematical physicists. They're mathematicians. All they do is work with amounts, whether it's charge, whether it's mass, whether it's the electron mass or whatever. They're always talking about amounts. So they're not moving particles, they're really moving amounts. And that takes us to the next issue, which is probability. Mathematical physicists can't predict where an amount, not a particle, where an amount will be next. Hopefully it's in your bank account, but usually it's not. Okay? Measurement, they rely heavily on measurement. Everything has to be measured. If you can't measure it, it doesn't exist. Niels Bohr essentially said that. Entanglement, you have action at a distance. It's done what? With black magic and spirits. In other words, they just wave their magic wand and say, it is so. We observed it in the lab. Did they observe something go between? No, they just observed an effect and they said, well, it's the quantum world. There's nothing in between, but that's the quantum world and we have to accept it. In other words, they have no physical interpretation for action at a distance in the quantum world. And they call that entanglement. And then common sense, that's the punchline always. That's the closing argument. It is arrogant for you to believe that the universe conforms to your petty and fallible human intuition and logic. Okay? So if you think it's irrational out there, it's because you're irrational, or maybe your rationality does not conform to Father Universe's rationality. Okay? That's the argument. And I have no problem with Father Universe's logic. I have a problem with the guy from quantum, when he tries to explain it to me, it's his logic that I'm questioning, not Father Universe's logic. In fact, I think that if Father Universe, God, Mother Nature, the devil, all of them came together, they would laugh at these guys and they would say, hey, your logic doesn't conform with ours either. No, they should have gotten rid of the particle a long time ago, but they never did. And that is really what has happened here. Okay, what do we propose instead? Well, we propose this. We're saying that two atoms are interconnected by what we call the electromagnetic rope. The atoms expand and contract at great velocity, and by doing so, they tore the rope. And it's that torsion along the rope that we call light. Okay? So that's the model. Okay? So you can see it is a little different than what mathematical physics proposes. Here's the construction of the atom, real quick like. Again, you have one thread. Remember, it's a rope that converges upon our atom. One thread goes through the center. The other one goes around and encapsulates those in the center. Okay? And here you see more or less what happens. All the ropes converging upon our atom from every atom in the universe. There you see the ropes, and only a single thread continues to the center of the other, of the atom, while the other one goes around and encapsulates the one in the center. In other words, if you take all the threads from the universe, right, of every rope converging upon our atom, from every atom in the universe, one thread goes around and that forms the electron shell. And that electron shell encapsulates what we call the proton star in the center. And it is this atom that expands and contracts, okay, and is going to produce light. What is light under our model? It's this. It's just the torsion of a rope. So this is how we explain light. Very simple, very straightforward. We can explain why the velocity of light is equal to frequency times wavelength, why that equation, the wave equation, matches the rope. In fact, it is the equation of a rope. You expand the link there, and you have fewer links for the same amount of rope. And conversely, if you contract the link, the length of the link, for the same amount of rope, you will have more links. That's frequency versus wavelength. We're done. C equals frequency times wavelength. The velocity of light equals frequency times wavelength is the equation of a rope. How do we do electricity? Well, here's the differences between what classical quantum and mechanics had and what we propose in its stead. According to classical mechanics, you have all these atoms and you have a little electron bead moving for whatever reason from atom to atom. And the flow of these beads is what they call electricity. Quantum mechanics got rid of the atom altogether and they just do it with electron beads. According to quantum mechanics, you do not need atoms. All you need is all these loose electron beads, and they move across space, and that's that flow of those charges, as they call, that constitutes what we call electric current or electricity. And what do we say? Well, we say that all these atoms, they are aligned, they are spinning in place in what we call a serpentine, that red line there at the bottom, the long one. all those little spheres there. Well, they're all bound, they're all merged into each other. They're electron shells which are merged into each other. And here I'm showing only atoms, but it could be molecules. And all these molecules are aligned and they're spinning. And that constitutes electricity. It's a torsion of many, many aligned atoms and molecules. Okay, so that's our model for electricity. And here you can see a different version of that. You can see the three versions. The one for classical mechanics, which was 19th century and before. Quantum mechanics, just the electron bead. And the rope model, which is the twirling of a serpentine. It's a torsion. When you stick your fingers into the outlet and you get a big shock, what you're receiving is an enormous torsion that is twisting you around, essentially. Okay, that's what electricity is. Because of that, we can explain also magnetism. According to the official version, what current is, remember, was the flow of these electron beads, charges as they call them. But then they cannot explain what those circular lines that go around the wire are. They cannot explain what a magnetic field is. And a field is simply defined as a bunch of values, mathematical values, amounts around the source, in this case the wire. Okay, so they just say it's just a bunch of numbers that surround a wire, or in the case of gravitational fields, a bunch of values surrounding a mass, for example the Earth. So all they talk about is fields, but they don't know what a field is physically. What they say, it's just a bunch of values around an object. What is a magnetic field according to the rope model? Well, you have the serpentine. Remember, it was spinning around. What it does is it loosens some of the threads that form the rope, and they begin to spin around the serpentine. And that motion, that sweeping around, that's what constitutes a field. Okay? And so how do we explain attraction and repulsion because of that? Well, here you have the model for magnetic attraction, magnetic repulsion. If you have two wires conducting electricity in the same direction, for example, in the top part there you have the two wires are conducting electricity in the same direction, and what we're saying is the threads are sweeping clockwise in both cases. When one comes down, the other one comes up, and they latch onto each other and pull one wire towards the other. And if you sprinkle iron filings over two wires conducting electricity in the same direction, you will get that pattern that you see up there on the upper left. Okay? And of course, the closer the wires are to each other, the more threads that participate, and because more threads participate, you have a stronger and stronger, ever stronger attraction between the two wires. It's exponential. On the other hand, you have repulsion. You can see the iron filing sprinkled over two wires carrying current in opposite directions. And what happens in that case, well, one goes counterclockwise, the other one goes clockwise. And the top and bottom there are in opposite directions, but I guess you get the idea. If you look at the bottom one, you have counterclockwise on the left and clockwise on the right. And what they're doing, the threads are hitting against each other, these gazillions of threads that are spinning around the wires. They're essentially forming this mass of threads, and they're pushing each other away. And that's exactly the opposite from what you see there with the attraction. And of course, all you had to do was switch the direction in which the wire was conducting electricity. Okay? Okay, and so here's like a summary of that magnetism thing. And the one I want you to focus on is on the one on the lower left. You can see that a magnetic field is something that has something in motion in it. It's made out of motion. Why is a field made out of motion? Well, you can see it there with the magnet that is put into water. They put this magnet in water, and you can see it's drawing all the iron filings one by one, slowly, gradually. So there's something that's moving in there that's attracting one iron filing at a time. And I'm saying that's the threads that move around. And you can see on the upper left, that coil there, it has the same, you can superimpose a magnet on there, south to north, and you can see that that's the direction in which the lines of force line up. Then on the right-hand side, you see that there is motion of the magnetic field going through the center of the magnet and out the other, from south to north. Okay, south goes out, north goes out, south goes in. And at the bottom, you see the rope model imitates that very well. What you have is the threads swinging around the magnet. They go into the south side, out the north side, and that's what produces attraction and repulsion, according to what I just explained a minute ago. Okay, so there you get the idea. And here's the rope summary, essentially, for each one of those phenomena. And you have light, which is the torsion. You have the atom, the construction of the atom, the fact that the atom is built by these same electric threads, electric and magnetic threads. Okay, and electric magnetic are just labels to be in line with convention. That's the only purpose of the word electric and magnetic. There's simply two threads. One goes around, the other one goes through, period. And then on bottom left, you see that the serpentine is the row of merged atoms, the row of merged molecules. They swing around and they swing the threads around. That's what's going to cause the magnetic field. Electricity flows into your eyes. Okay, and so it is at 90 degrees to the magnetic field. And then on the bottom right, you see how a magnet attracts and repels another. When they're both clockwise, they attract. And when one is turned around in the opposite direction, it goes counterclockwise, okay, and they push each other away. Okay, so the model matches very well with observation, with experience, okay, and so we think we have a good case for proposing the rope hypothesis as a mediator for light, for gravity, for magnetism, electricity. But let's get to gravity, which is the one that's the odd man out right now, and the one that, by the way, quantum mechanics cannot explain at all. Okay, so keep that in mind. Quantum mechanics has no provisions for gravity. And here is the model that essentially the mathematical physics uses particles, and that's essentially quantum mechanics, but they cannot explain this. Okay, here's your particles, and here's the astronaut, and why are the particles pushing him down to Earth? I mean, why would they be pushing him if they're just a bunch of particles? And of course, quantum mechanics cannot explain that. That's why quantum mechanics cannot explain attraction with particles. And here you have a macro scenario. Quantum mechanics deals with a micro scenario, but the issue is the same. They cannot explain the force of pull with particles. That's the issue. What does general relativity propose instead? Well, they propose that there is warp space, and the astronaut essentially slides along this fishnet down to the Earth. Problem with this is that space-time is a concept, and it's not an object, so we don't know what the astronaut is sliding along. Okay? You can't slide along time because time is a concept. You can't say that you warp time and that the astronaut is sliding through time because time is not a physical object. And what does the rope model propose? Well, that every atom in your body or the astronaut's body is connected to every atom that comprises the Earth. And so as the astronaut falls to Earth, the ropes fan out and he falls ever, ever faster because of that, the fact that the ropes are constantly fanning out. Okay, so he is attracted to the Earth, not because there's a pull, but because at each location, as he nears the Earth, the ropes are farther and farther apart. That's why. Okay, so there is no pull under the rope model. A lot of people think that the ropes pull. No, the ropes don't pull. This is done by aggregation. Okay, each rope pulls independent pulls. I use the word pull because there's hardly any other word. The correct word is there's tension at every location. So there is no pull. Okay, and that's a concept that takes a while for a lot of people to master. Okay, so because of that, general relativity says that if our sun were to disappear, it would take 8 minutes for the Earth to fly away. Why? Because we're on this depression that's caused by the sun, and it's a depression in time. You're pushing time downwards. Okay, you're bending time. You're warping time, and you have this depression, this roulette, so to speak. And a little ball called the Earth rolls around this roulette. And this is what it looks like, more or less, according to mathematical physicists. And what they say is that, look, if the sun were to disappear, right, well, the Earth would not fly out instantaneously. It would take about 8 minutes for the gravity waves to reach the Earth, because nothing can travel faster than light. Okay, so we wouldn't hear about it. We wouldn't see the sun disappear, because it would take a long time, for 8 minutes, right, for that information to reach our eyes. What do we propose instead? Well, we say that obviously that's nonsense. Partly because there is no such thing as space-time. Space-time is a concept. You can't use concepts in physics like if they were physical objects. So this is the way we do it. We say, look, the Earth is swung around the sun, but because all atoms of the Earth are connected to every atom of the sun. Okay, so the sun twirls the Earth around itself like a bunch of Lilliputians would be swinging Gulliver at the end of a bunch of ropes. That's essentially what it is. And so the sun cannot disappear, first of all, because it's part of the grid, part of the single thread that forms all matter in the universe. That's the first thing. But assuming we did a little magic and we made the sun disappear, the Earth would fly out instantaneously, because there is nothing holding it to the sun at that point. So you can see that we have some differences with mathematical physics. Okay, that's essentially the summary of what we propose. Now what happens? A fellow asks a question. He says, where does God fit into all this? Where's God? Okay, so let's put God in there. Okay, let's include poor old God. Okay, and well, this is what the guy said. Okay, he said, he asked me, he said, Bill, can you make a video explaining your thoughts on God? Okay, so this is the video. I'll be very brief on it, okay, because I don't think it takes that much time. And so here's the proposal again, the single thread. Okay, and there's God. Well, God has two choices for any proponent of God. Either God belongs to the grid, to this single thread. He's part of that grid. He's part of the ropes and atoms that form all the matter in existence. Or God is not. If God is not, well, he's a little irrelevant, first of all, because for one, he cannot contact me. The only way people can contact me is through the sense of touch. Okay? Now, we say we have 5 senses, but we only have one sense, and that's the sense of touch. If you don't have touch, you're out of touch with the universe. So if God wants to be in touch, he wants to be in touch with the universe, with you, with me, with anything, God's got to be part of the grid, because the only way we can have touch in our universe, according to the rope model, is for anything to be part of the grid. Okay, you have to be part of that single thread that forms all matter in existence. Anything outside of that, assuming there is something there, no problem. We can make that assumption. But if it's not connected to us, it cannot communicate with us. You might say, well, God is all powerful. Okay. Yeah, God might be all powerful, but I'm not. And I hope he understands it. Please, God, be aware I'm not all powerful. So if God wants to communicate with me, he's got to communicate with me through some form of physical contact. If he's going to do it by sight, by sound, by taste, I don't know, by hand, whatever way he wants to do it, he's got to be in touch with me. Now, again, God can be all powerful, and I do respect that, but I'm not. Okay, so if God wants to communicate with me, he's got to do it through the sense of touch. And for that, he's got to be part of the grid. He's got to be part of the atoms. Otherwise, how does he, communicate with me? Okay, this is where the problem is. And so this is poor God here again. okay, he's got to be part of this grid. Okay, if God wants to communicate with me, he's got to be either an atom or made of atoms. He's got to be part of the rope. He's got to be some of that. Otherwise, he can't communicate with me because, again, I'm not all powerful. Okay, so I'm so sorry. I wish I were like him, and I do respect his power. But poor God, you know, he would be out of touch with me if he can't touch me. The only way he can touch me, okay, is if he's part of the atoms and the ropes that form matter in this universe. Okay, okay, so that's in a nutshell God. Okay, there's another issue with God. I think I have it here. Let's see. Yeah, we have to have the, in order to analyze the issue of God from a physical point of view, you first have to lay the foundations of physics. Okay, and no one has done it in the last 2,000 years, at least, for sure in the last 10,000 years. And so we had to do it at the beginning of the 21st century, at the dawn of the 21st century. And these are the things that you have to keep in mind if you want to do physics, real physics. I mean, physical physics. Physical physics, what is that? We're going to explain physical phenomena with objects. There's got to be an object mediating every transaction, every phenomenon out there, okay? Without objects, what's happening? What's going on? You got to have an object. And no one has realized that in the last, 10,000 years again? So we have to define what an object is. We call it something, we call it object, we call it a thing, body, a substance, physical, entity, any of those words, they're all synonyms. Medium. So something, that which has shape. Nothing is that which doesn't have shape. Now we have two antonyms, you know, something and nothing. We can use them consistently, rationally. We know what we're talking about. One has shape, the other one doesn't have shape. Straightforward, okay? From there, you can see the others there. We want to jump to exist. Exist requires that the object, in addition, have location. So if God wants to exist, not only does he have to be an object, he can't be a concept like intelligence or grace or, love or something like that. No, God has to be a physical object. Then he exists. He can exist. He has a chance of existing for the purposes of physics. But in addition, he's got to have location. There has to be distance between God and me. There's got to be a straight line of direction from my nose to his nose. Okay? So God cannot avoid. He can hide in the 26th dimension. He can be magical. Doesn't matter. If God is a physical object, and he's got to be, if he wants to exist, otherwise he doesn't exist by definition, there's got to be a straight line of direction from him to me. Okay? Straightforward. Okay, and if God meets those conditions, then he exists by definition. So here's the definition of exist. Okay, we apply it to God. Okay, it's got to have physical presence. That's what exist means. He's got to be an object, and it's got to have location. In other words, he's got to be that which has shape, and that God there has shape. That's the one. Who is it? One of the turtles drew in the 16th century, and there's got to be distance between the objects in the universe and God. Every atom in the universe, there's got to be a distance between that atom and God. Okay, and then he exists by definition. Okay, otherwise he doesn't exist by definition. And no, we do not determine the existence of God through the senses. We determine the existence of God by definition. If God meets the definition of exist, God exists by definition, pursuant to the definition. That's simple, very simple, straightforward, very rational. Okay. And so that automatically overrules and outlaws three religions. One is theism in all its forms. That means typically traditional religions, the ones who rely on this supernatural God, supernatural being, spirits, angels, whatever you have in your mind. It outlaws all that because you have to make your God visible by drawing God. If you can't draw God, then God does not exist by definition. Michelangelo drew his God, and so now we know that's Michelangelo's God right there, the one we can point to. Okay, so the only thing that we're missing now is for that God to have distance with us. The picture, the pen, the picture doesn't have distance. The ink or the paint, the colors that Michelangelo used, they have distance with respect to us, not the image. The image does not have location. If God wants to exist, he has to have location. That means there's got to be distance between some real part of his body, some atom that forms his body, and an atom in my body. Otherwise, he doesn't exist by definition, not because I believe or not. And that's when we outlaw these guys, the theists, the atheists, and the agnostics. Because one guy says, I believe that God exists. The other guy says, I know that God does not exist. And the third one says, well, I don't know what experiment I can run. I don't have any proof yet that God exists. Well, none of them follow the scientific method. The scientific method is, let us assume that God exists. God can only be an assumption, and if you make that assumption, let us assume that God exists, now you can explain your theory. That's the way the scientific method works. And these people just follow the mathematical method, which is, I'm going to prove it to you. I'm going to convince you. We don't convince in science. We don't prove anything. We don't prove theories. We explain the mechanism. Okay, that's what we do. And in order to explain the mechanism, you have to provide the objects. In this case, we provide good old God as an object, and that is fair game. You can provide God as an object. You can't provide space-time as an object because space-time is not an object. And so space-time is even in worse shape than God in that sense. I can imagine God, guy out there with a magic wand, I cannot imagine space-time, and no one can. Not four-dimensional space-time. I cannot even imagine time. What are you going to draw? What are you going to put as an image for time? A clock? 2 seconds? No, so space-time does not qualify as a physical object for the purposes of physics. Okay, so there's my 10 cents worth on God. God cannot exist if he's a concept. God has to be an object. And if God is an object, that's not sufficient either. He's got to have location, meaning distance from me to him. Okay? And to all other atoms in the universe. He's got to be part of the grid under the rope model. Okay? He's got to be part of that single thread that turns into atoms and ropes that interconnects all atoms. Otherwise, God does not exist by definition. Maybe in another universe, not this one. Okay?